Before we get into that discussion of MST, I do want to draw a very clear line in the sand here when it comes to our per VLAN spanning tree versions, PVST and PVST plus. Now, the name is the recipe, per VLAN spanning tree. The Cisco proprietary PVST runs a separate instance of STP for every VLAN. The good of that is that it allows for much better fine-tuning of spanning tree performance than STP does. Of course, we saw that with some per VLAN load balancing in an earlier video. The bad is that running PVST does mean extra work for your CPU and your memory. Okay, but it's usually worth the trade-off. The ugly is that PVST itself, the original PVST, requires ISL trunking. And we know that we're usually going to see .1Q trunking. I'm not saying there's no ISL out there, but we see a lot of .1Q, and that's what we use here in the labs as well. Now, not only that little problem there, but PVST doesn't play well with common spanning tree, and more on that in just a moment. So Cisco came up with PVST Plus, which has the same functionality as PVST while having the capability to run over ISL or .1Q trunks. The reason I mention this is that I do it and a lot of other people do it, almost everyone I know does it. We just call PVST Plus PVST. And when you're working out in the real world, that really doesn't matter that much. But when you are taking the exam, you might want to draw that line. PVST requires ISL trunking. PVST Plus can run over ISL or .1Q. Good thing to keep in mind. Speaking of common spanning tree, what the heck is it? Well, when .1Q is our trunking protocol, the trunk is using a common instance of STP for all the VLANs. Hence the name Common Spanning Tree, CST. I'm going to come back to that in a minute, but let's go to MST right now. MST is defined by IEEE 802.1s. It earns its name from a scheme, take a deep breath, that allows multiple VLANs to be mapped to a single instance of STP rather than having an instance for every single VLAN. And you might look at that and say, well, wait a minute, don't we like per VLAN spanning tree plus? I mean, we like that. We do, but on occasion the overhead might just be huge. MST serves as a middle ground for us because we have CST where we have one STP instance, we have PVST, one STP instance for every VLAN. MST allows us to reduce the number of instances without knocking it all the way back to one. Now, I am always up front in real world with you, and I'm going to be especially that here. You're getting a taste of multiple spanning tree here in your CCNP studies. This is not an exhaustive look at MST, and this is really something you know the old cliche, measure twice, cut once. You want to measure about 5 times before you start cutting with MST, because MST was actually designed with enterprise networks in mind. And it can be really useful in the right environment, including an example we're going to look at in a moment. But it's not for every single network. The configs can get really complex, and you definitely want to do your planning beforehand. But again, no matter the size of the network, the basic purpose of MST is to cut down on the number of STP instances because we're going to map multiple VLANs to a lesser number of instances. Let's say that we had traffic for 750 VLANs coming in here and 3 switches that can handle some or all of the traffic. Well, with CSP's one STP instance, one switch would end up handling all the traffic. And we couldn't perform any per VLAN load balancing because that requires multiple instances of STP. With PVST Plus, we can configure per VLAN load balancing. We did some of that earlier. So we could spread the workload around a little bit. Seems a little more efficient. But as we know, everything we do in a Cisco switch has a cost in terms of CPU and or time. With PVST Plus, if we have 750 VLANs, we have 750 STP instances running. That's a lot of STP instances. MST gives us this middle ground where we can map multiple VLANs to single instances of STP. Now, MST configuration, what we end up doing is logically dividing the switches into regions. And the switches in any given region have to agree on 3 values. And anytime we have something like this, we really should know what those 3 values are. The MST configuration name, the MST config revision number, and the MST instance to VLAN mapping table. Now, we are not sending the table between the switches all the time, because what happens is these MST BPDUs, they're used to allow other switches to see what values are being used by the sending switch. Now, switches that disagree on any of these values, they're considered to be in different regions. And those BPDUs do contain the config number and the config revision number, but when it comes to that mapping table, it's not sending the entire mapping table. It's sending a digest value that is derived from the mapping table. Now, I know this is hard to wrap your mind around the first time you see it, or the first time you hear about it. But a good way to get a mental picture of the interoperability of MST and CST is that CST covers the entire network, and MST is like a subset of the network. CST is going to maintain a loop-free network only with the links connecting MST network subsets. MST's job is to keep a loop-free topology in that region itself, because when it comes to these regions, in this example and in any other, CST, not only does CST not know what's going on inside that region, it doesn't want to know what's going on inside that region. That is actually up to the IST. That's internal spanning tree, and it's the IST instance that is responsible for keeping everything inside a given region loop-free. That's all there is to it. Now, we can have up to 16 MST instances in a region. They're numbered 0 through 15. MST 0 is reserved for that IST instance, and only the IST instance is actually going to send MST BPDUs. When you see MST instances numbered, they are decimals, not hexadecimals. Just wanted to throw that in. Now, let's go ahead and take a look at a basic configuration here. And I will call up on switch 3, leave it a little higher this time. And let's see. Knowing how to enable the mode itself couldn't hurt. It's just spanning tree mode MST. No options, and that's it. Now, let's drop into configuration mode. You are going to see the line protocol go down and go up, which it did. And let's see, let's go ahead and go into config mode. I want to show you a couple things in there. You have to go spanning tree, MST, and you've got some different and similar looking values here. We're not going to get into setting the timers or the hops, but what we will do is go into MST configuration submode. Not as much fun as it sounds. And you'll notice the prompt changes to config-MST. This is where you actually set the name, set configuration name, the revision number, set configuration revision number, which you have to increment manually, by the way, every time you make a change in the config. I'm not kidding. And instance, where you map VLANs to an MST instance. We'll do all three of those. What I want to point out first is the difference between the top two commands, abort and exit. If you type abort, you leave the config mode and you abort your changes. If you type exit, you exit the mode and you apply your changes. Don't drive yourself crazy by typing the wrong one. So let's just go ahead and take a look at a couple of the options here. Name, we'll just set it CCNP since that's what you're going to be. Revision, I could just set that to 0, I believe, and I'll start with 1. And it's the instance I want us to look at in particular. And we're going to go with instance 1, and then you have to type the word VLAN, and then you enter your range. So if I was going to assign my first 250 VLANs to to instance 1, I simply type 1 through 250, and I should be in good shape. Should be. Now, of course, I want to verify with show pending. And you can see it's going to show you your pending config, the name, the revision number, how many instances are configured. And note that I did not manually do anything with instance 0, but yet there we are with VLANs 251 through 4094. Every VLAN is mapped to instance 0 unless you and I, the network admins, manually change that, manually change their assignment. One more thing, did you notice anything really odd about that particular show command? I had to run it in MST configuration mode. And I tell you what will happen. You could type show pending because you're going to do it sooner or later if you work with MST. I've done it before. You type show pending at the same enable prompt where you type so many other things or so many other commands. Or actually, you don't go that far. You could just do it right here. And I did leave there without changing it, so it's going to go down and up. And let's see, if I run show pending there, I'm going to get this. I get the caret. And I'm like, huh? What? What do you mean? You have to be in configuration mode in order to change. In order to run show pending, you have to. Also, like I said, I just left without saving those changes, so I would have to go in and apply them with exit. And that is really about it for MST. Again, just a taste, about a 10-minute taste here to get you started with it, get you through the CCNP switch exam, certainly. But if you are going to work with this in the future, or your network does now and you want to learn more about it, I would do some additional reading out at Cisco's website. I will see you in the very next section, because what we're going to do there is start aggregating some of these links and building some Ether channels. I'll see you there.